Okay, the purpose of this video is to help you balance chemical equations. So we want to be able to take an equation and balance it. I guess to begin with, just why would you balance a chemical equation? I guess it's like a recipe similar to that, where when you have a chemical reaction, you have so much of something reacts with so much of something else to produce a certain amount of something else and a certain amount of something else. And these numbers in front help us do some good stoichiometric calculations on, like, if I have so much of this, how much of that would I need? Or how much of this stuff gets produced. So I need to have these ratios in front of each one of these compounds to let me know how much of each thing that I need. Okay, so this is a good example of a chemical equation that I would need to balance. So I have glucose reacts with oxygen to produce carbon dioxide and water. It's basically cellular respiration. That's what's happening inside of us all of the time. So let's go get a couple of ground rules for balancing equations. First off, and we won't do this in this video, but this is an important part, is making sure that you have each of the components, the reactants and the products, written properly. If you were to like throw a different number in there somewhere, it would mess up the equation. So you need to make sure that you have your reactants products written down correctly. And that's part of writing the formulas. Then write an unbalanced equation with reactants on the left, products on the right. And then you balance the equation. Typically they say starting with the most complex molecule, but you could start there, but you basically make sure you have to have the same number of H's on, if you have 10 H's on one side, you have to have 10 H's on the other side. So you look at the reactants, you look at the products, you have to have the same number of things on each side. Here's some guidelines to help you. Look for groups of atoms. And what I mean by a group of atom is like, say, a sulfate. If there's a sulfate all together like that on one side, and it's on the other side, you can treat that as a group. So instead of saying you have one sulfur and 4 oxygens, you could say I have one sulfate. And then just compare those. That helps a little bit. Any number that's in front or a coefficient of a molecule applies to every atom in that compound that follows. And subscripts only apply to the atom that they are subscripting, or that they're right below. For example, if I have SO4, that 4 only applies to the oxygen. It doesn't apply to the sulfur. All right, now I just want to go through 5 or 6 equations, sort of show you how I would balance them, and then you need to practice them on your own. So here's one. I have hydrogen reacting with chlorine to produce hydrogen chloride gas. Notice here I've got 2 hydrogens, but over here I only have 1, not balanced. And what I need to do is fix that so it is balanced. 2 chlorines, here I only have 1 chlorine. When you're balancing an equation, if you have all the reactants and products written properly, you can only put numbers out front in the coefficients. There's no change in these little subscripts, even over here. You can only put numbers out front. So here, if I say I have 2 hydrogens over here, to get my 2 hydrogens, I can't put it here, I have to put it out front. But this is a coefficient. Any coefficient out front applies to both things behind it. So that means putting a 2 here means I have 2 hydrogens and 2 chlorines. Over here, I've got 2 chlorines. Here, I've got 2 chlorines. 2 hydrogens, 2 hydrogens. This equation's balanced. One thing that helps some students when they are balancing equations is to sort of draw a line and have like hydrogen and hydrogen and chlorine. Or maybe they do it this way. I don't know about the line. Whatever, something like this. You have a hydrogen and a chlorine, and then on the left side you write how many hydrogens you have on the left side, and on the right side you say how many hydrogens you have there. And you keep manipulating the coefficients up here until these numbers match on either side. Maybe I'll try that with another question. Let's try this one. Okay, so I have potassiums, chlorines, and oxygens. Notice that I have to have if I have potassium here, I have to have a potassium over there. You can't just sort of lose a potassium. unless it's a nuclear reaction, which then you can change from one atom to another. But in normal chemical reactions, if you have a potassium here, potassium has to be on the other side. Currently, I have one potassium there, and over here I have one. Chlorine, this 3 only applies to the oxygen, so there's only one chlorine here. Over here, there's only one chlorine. I'm looking pretty good. Here I've got 3 oxygens, and on the other side I only have 2 oxygens. Not balanced. I got to fix things. Often you can think of like a common denominator to help you balance. So here if I have 3 and 2, I'm thinking I got to go to 6. So why don't I put a 3 here? If I put a 3 there, that gives me 3 or times 2, that'll be 6 oxygens on this side. But over here I only have 3, so I could fix that by putting a 2 out front. If I put a 2 out front, 2 times that 3 there will give me 6 oxygens. Now my oxygens are balanced. But by putting a 2 there, that also gives me 2 potassiums, and it gives me 2 chlorines. And you probably see what's coming up now. If now I just put a 2 right there, then this changes to a 2, the chlorine changes to a 2. Now everything is the same on each side, so now the reaction is balanced. If this helps you by putting the atoms down and then counting on each side, do that. Hopefully you'll get to a point where you don't have to do that, but if you don't, if that works for you every time, go ahead and do that. Here's another one. I haven't balanced this one. I see something goofy right there, H3 and H2. I'm going to maybe try and get a common denominator with that. I don't know if it'll work, but I'll try. I'll maybe put a 2 here. That'd give me 6 hydrogens. Over here, I'd need to put a 3 there, and that'd give me 6 hydrogens. Hydrogens are good. Okay, here I have 2 nitrogens. Over here I only have 1, so I'll put a 2 there. That'll give me 2 nitrogens. Now let's look at oxygens. I have 2 oxygens here. Over here I've got 2 plus another 3. So altogether I've got 5 oxygens on the right and only 2 on the left. I guess I could put a 2.5 here, because 2.5 times 2 does give me 5 oxygens, and then it would be balanced. Typically we don't deal in halves though in reactions, although if you're doing stoichiometry it works fine, but typically we would like to have whole numbers there. So if you ever get one where you have a half like that, just an easy thing to do is just to double everything. So times this by 2, so that would be a 4. Times this by 2, that would be 5. Times this by 2 would be 4. Times this by 2 would be 6. So my coefficients I could put out front 4, 5, and 4, 6. Let's try some other ones. Oh, here's a good one. Double replacement reaction. So barium hydroxide reacting with sulfuric acid to give me barium sulfate and water. Notice that this one has those groups that I was talking about. Like here I've got a hydroxide, and over here, well, water I don't have a hydroxide, but you could write water as HOH. So there it's got a group. So rather than saying I've got 1 oxygen, 1 hydrogen, or 2 oxygens, 2 hydrogens, I can say I have 2 hydroxides. So if I have 2 hydroxides here, over here, I just have 1 hydroxide. So I could put a 2 out front of that. That would give me 2 hydroxides. But that also gives me 2 hydrogens. So over here, oh, I have 2 hydrogens already. Oh, that's good. I have 1 barium, 1 barium. Here's a SO4. Notice I could call that 1 sulfur, 4 oxygens. But since I see the exact same thing over here, I'm just going to say that's 1 sulfate. And over here I have 1 sulfate, balanced. Let's try a couple more. This one looks like a good one. And again, feel free to pause and try and balance these on your own, then come back and press play and see how you do. Okay, I've got 2 antimonies here, only 1 there. And often what you do is you look for things that are out of kilter. This sulfur, it looks out of kilter as well. You're going to have to fix that, but let's start with antimony. 2 of those, I'm going to put a 2 there. But then that gives me 6 chlorines. So over here I only have 1 chlorine, I need to put a 6 there. But then that gives me 6 hydrogens. Over here I have a 2 there. If I put a 3 there, that gives me 6 hydrogens. But then that gives me 3 sulfurs, which I have. Done, balanced. Notice no number there, written there. We assume that to be a 1. If you don't have one in there, it'll be a 1. Okay, let's try this one. Uh-oh. Gee, I don't know how to balance this one. Well, let's give it a shot. So here's 1 sulfate. Here's 1 sulfate. I think I can leave those at 1 and 1. They should be good. Here I've got an NH4, but there's 2 of them. So that means this 2, I have 2 of everything here, but I don't have an NH4 over here. I've got an NH3 and then a hydrogen. So this does mean I have 2 nitrogens. I'll have to separate that out. So 2 nitrogens, I'll put a 2 here. So that's going to give me 2 nitrogens and 6, 7, 8 hydrogens. Over here I've got 2 nitrogens and 8 hydrogens. Oh, so it's balanced. Done. Notice that with a reaction, what you do is just start meddling around, mucking around, and see what you can do to balance and make sure you have the same number of atoms on each side. Here's a bunch more. I'll just maybe try a couple of them. Let's go with this one. 1 Ag, 2 Ags. Let's fix that. Put a 2 there. But then that gives me 2 nitrates. Do I have a nitrate over here? I do. There's a nitrate there. There's only 1. Notice the 3 belongs with the whole nitrate, so it's just a 1 nitrate. Since I have 2 here, I need to put a 2 there. But then that gives me 2 hydrogens, which I have. I have 1 sulfur, balanced. Again, I could put 1s there if I want. I like those. Let's try another one. Zinc, 1 zinc, 1 zinc, 1 lead, 1 lead. 2 nitrates, 2, it's balanced. Don't have to do anything with that one. Try this one. NaNO3, NaNO2 plus O2. So this and this are different, so I can't treat them as a group. I have to separate them into nitrogens and oxygens. Okay, so it looks like the oxygens might be the funny thing. Maybe let's double this. That'll give me 2 sodiums. Let's put a 2 there. So 2 sodiums, 2 sodiums, 2 nitrogen, 2 nitrogen. But here I've got 6 oxygen. Over here I've got 4 oxygen plus another 2 oxygen. So that gives me a total of 6. I'm balanced right there. This one, chlorines are a little off kilter. Let's do the common denominator thing again. 2 and a 3 goes to 6, so I'll put a 2 here. That gives me 2 aluminum, so I have to put a 2 there. I also now have 6 chlorines, so I need 6 chlorines over here, so I put a 3. You getting the idea? A couple more and then we'll call her good. This last one looks like a good one. Let's do that one right. Maybe these 2 and we'll call her done. Okay, 1 calcium, 3 calciums. Have to fix that. Let's put a 3 there. So 3 calciums, 3 calcium, that's good. Now, here I've got hydroxide. There's a 2 there, so there's 2 times 3, so there's 6 hydroxides here. Over here I just have 1, so I need to put a 6 right there. So that gives me my 6 hydroxides. Now I've got 6 hydrogens. Over here I just have 3, so I could put a 2 in front of that. That'll give me 6 hydrogens. But it also gives me 2 phosphates, which I have. Done. Balanced. Last one, combustion reaction. 6 carbons over here, maybe I'll put a 6 there. Okay, 12 hydrogens. I need 12 out of this, so I got to put a 6 there. Okay, so let's take stock here. 6 carbons, 6 carbons. 12 hydrogens, 12 hydrogens. Now let's look at oxygens. 6 times 2, that would be 12 oxygens here. 6 times 1 would be another 6. So on this side, I've got 18 oxygens. Here I've got 6 already. I need to get 18. So if I were to have 6 there, and I need to get 18, I need 12 more oxygens. So what number would I have to put there to get me my 12? Yeah, put a 6 there. Okay, hopefully that gives you some examples of balancing chemical equations. It's critical to be able to balance chemical equations because when you are starting to look at how much of something reacts to form something else, if you don't have a balanced chemical reaction, you're going to get the wrong answer. You have to have a balanced chemical reaction to do any of that stoichiometric calculations. Okay, hopefully that helps you.